Hello everyone, my name is Daryl. I work as a software developer, and in this video you'll see how I naturally work through a LeetCode challenge. This is a problem that I'm seeing for the first time, and I'll explain myself as I work through it. My solution won't likely be the best or most efficient, it's just going to be the first one that I just kind of work through. So this question sounds pretty easy just based off of the name. This is number 27 called remove element. So let's go ahead and read the problem. Given an integer array nums and an integer val, remove all occurrences of val in nums in place. The relative order of the elements may be changed. Since it is impossible to change the length of an array in some languages, you must instead have the result be placed in the first part of the array nums. More formally, if there are k elements after removing the duplicates, then the first k elements of nums should hold the final result. It does not matter what you leave beyond the first k elements. Return k after placing the final result in the first k slots of nums. Do not allocate extra space for another array. You must do this by modifying the input array in place with O1 extra memory. There's a custom judge for this one. This one looks pretty similar to the last one we did, to be honest. What's actually happening here? So you have an input, it has this array, val is 3. And so the output, so this just returns an int, and that's the size of the final array. It's pretty similar to the last one. It's just that we're removing that number specifically. So you're just removing whichever value they tell us to. And they're passing us the int array and the val. Okay, I mean, this should be pretty easy. So I'm going to copy over this function to my code. We can get started on working on the solution. So we're going to do a similar solution to what we did for the last one, number 26. It's going to be a little bit different, but pretty similar. So first, let's create a var current write index. Then we're going to create another variable. And in this case, I'm just going to set it to -1 because in this problem, the values are going to be between 0 and 50. Now we're going to loop through this int array. First, we're going to do if the value is not equal to the current value, continue. And so what this is going to do is if the value that we're at in the array is not, let's actually change this to val. There we go. If the value that we're at is not equal to the value that we're looking to remove, everything's fine and we can just continue. Let's actually change what we're doing here slightly. So this stuff was kind of copied over from the last problem. But instead, we're going to create a variable called amount to move back. We're going to set it to 0 initially. Let's change this check to be equal to the val. So if the value that we're at is equal to the val that was passed in here, we want to increment amount to move back and continue. If not, then we want to set we're going to need the index. It's funny because with the last problem, I had this with index and I never used it, but this time we actually need to use it. So nums index minus amount to move back equal to value. So basically, once we find the value that we want to remove, we're just incrementing this, and then if it's not that value, we're just going to move it backwards in the array, depending on the amount of this value that we find as we're walking through it. And then after this, we're going to return. Okay, so we're going to need to know have a way to get the correct size. And we can remove these explicitly declared types. So whenever we move one of these values, we want to set last index equal to this, and then since we're duplicating code here, let's make that a val. And then use that in here. And then try returning last index. Okay, so I'm going to go ahead and throw this into here and just see if we fail anything. Okay, we got the wrong answer. What do we got? Input was 3, 2, 2, 3, and 3. So it should be 2, 2. My output was just 2. When it should have been 2, 2. So let's really quickly just kind of look through it. So we're setting those to 0, looping through nums. If the value matches that, we're adjusting that up. So in this first case, if we run through this loop, it would be a 3, which is equal to that value. So it would just be setting this to 1. Then it would start again, and it would retrieve the value 2, which would not be equal to this. So it would go down here. Set adjusted index would be 1 minus 1. So that would bring it back to 0, which is correct. It would set the value at 0 to 2. And then last index would be equal to 0. Then it would loop through again and see a 2 for the third value. It should go down here, say the adjusted index equals 2 minus 1. So this should be 1, which should be setting the second one to that. Okay, so just kind of looking over the logic, I don't see any particular issues. The logic, from what I can see, checks out, so we're going to need to debug it here. And I'm sure the answer will become obvious. Let's see if we can just run just create an int array. See if I can just set it like this. Okay, int array of, pass in those values. And then we'll just pass in 3. Make that a val, that's fine. So let's just do a debug there. I'll switch over to full screen for this. Okay. So that's all as expected. Now we're going to go in here. The first one is 3, so it should go to here, increment that. That's correct. And now it's going to see a 2. So it's going to go here. The adjusted index is 0, which is what I expected. So here, now it's 2223. That's what I expected. And we set that to 0. Now we go through it again. We see a 2. So it goes down here. Adjusted index should be 1. We're setting adjusted index at 1 to that value. And last index is now 1. Then that's just adding 1. And then here it's returning last index. I see what the problem is. Problem is that we just need to add 1 here, because it's expecting the size and not the last index. So let's run the code now. Okay, that one got accepted. Let's go ahead and submit. Wrong answer. So when you give it a 1 and it's a 1, the output was a 1. I know why, because that's happening because we're returning last index plus 1, but last index starts at 0. Let's start last index at -1. I think that'll fix the problem. So let's just run the code on the sample example again. Accepted, and let's submit. All right, there we go, accepted. And that's apparently a really good answer to the problem too, with the runtime being faster than 95% and the memory being faster than 99.71%. All right, that's fantastic. So let's quickly go over the code. So first we're creating this variable amount to move back equal to 0. Basically what this value is whenever we encounter a value in the array that is not the one that we're trying to remove, if there are previous entries of the value that we want to remove in the index, we need to move this value back. So if we are at the third of the 4 values and there's been 1 3 already, we need to move it back to the spot number 2, to the previous spot. So that's all this is tracking. Obviously at the start it's 0. Last index, this is just tracking how big of an array we need to tell it at the end, the actual correct size. I had to change this to -1 from 0 for the case in which we had one array where it was of size 1 and we wanted to remove the 1 value that was in there. So the right answer was actually 0, since all that code ended up running was seeing this, adding that, and then returning this plus 1, which is wrong, because then it was telling it that there was 1 value in there. So that's why this is -1. Then we simply need to loop through the index. If the value is equal to the one that we want to remove, all we're going to do is add 1 to that, which is going to make it so that all future values will move back 1 further space, and continue, which goes to the next iteration of the loop. Here we are creating this quick little adjusted index value since we're going to use it twice here. It's just the current index minus the amount to move back. And we use that so that we can set, so if we're in the third slot and we're trying to move it to the second slot, then we're going to do that right here, overwrite the second slot with the value that we currently have. And then we're setting last index because now that, since we just found another value that is not being removed, we need to set the current index to the last index. And then simply at the end here, we're returning the last index plus 1. And one thing we could actually do, well, actually, I think this is fine. I was going to say we could add the 1 in here, but then I don't like that last index is a bad name for it then, because then that's not actually true. So I'll just be leaving it as it is. So, all right. Hope you guys enjoyed that and it helped you guys find the solution. Thanks, and see you guys next time.